Okay, so first problem says expand and add. So I'm going to start with the lower bound and put it in for n right here. See what I get out. I'm going to do that for all of them. 2 minus 4 times 2 minus 1 then. I'm going to go all the way until my n is the same as what's in the upper bound. Whoops, I wrote 3 and 1, which is 6. So I need to go all the way to 6. So now I have written all of them out, and then I have to figure out what each of them is worth. I'm going to do this quickly because we've done this a lot lately and I think that you're getting it. So I'm going to get 2 and then -2 and then -6 and then -10 and then -14 and then -18. Remember that you can just use your calculator to figure all of those out. And then again, it's totally fine if you want to just take all of these numbers, 2, -2, -6, -10, -14, and -18, add them together in your calculator, and your answer should be -48. Okay, the next one is the same process, except this is a geometric sequence, and it looks like our lower bound is 2 here, so just be careful. The first thing we're going to put in is 2, and then we're going to go 3, and then we're going to go 4, but then we'll be done because that's what the upper bound is. So let's start with 2, 27 times 2/3 to the 2 minus 1. Remember that the exponent is on the fraction, so the whole thing. Then I have to do 27 times 2/3 to the 3 minus 1, and then I have to do 27 times 2/3 to the 4 minus 1. This is one where it's really important that you use your calculator because I just want to make sure that you're being careful. And so we should get 18 and then 12 and then 9. Just kidding, not 9, 8. There we go. Okay, so then 18 plus 12 plus 8 is 38. Our solution is 38. Okay, the next one, say we're using the geometric series formula. It's written right here. So we need to identify what G1 is. We need to find R, and we need to find N. And G1 is going to be the first term, and that's always written like that right there. So G1 is 1 in this problem. R is the thing that has the exponent on it, so R is -2. And then N is the number of terms that we're adding together. And so if we're adding steps 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, that's 10 numbers we're adding together. So then to get our answer, we do Sn equals, well, G1 is 1 times 1 minus our R is -2 to the N is 10, divide the whole thing by 1 minus R. R is -2 again. Okay, so I would put this in my calculator, and so here goes. 1 times parentheses 1 minus parentheses -2 there we go, to the 10th, all divided by 1 minus -2. And our answer is -341. So there it is. Okay, same deal here. We just have to find G1, R, and N. Our G1 is 7. Our R is 4. And our N is 8. So I can just take my same Desmos screen and do that. So I'm just going to change, wherever I see G1, I'm going to change that to 7. I'm going to change r to 4. And then I'm going to change n to 8. There it is, 152,915. There it is. Okay, the next one says find the sum of the first 10 terms, and so n is 10 here in the sequence, or in the series. A1 is our first term, so A1 equals 3. And we don't know what an is, but we do know that n is 10, so we need to find a10. So an is our sequence formula, so we'll write 3 plus, and our common difference here is 2. So if I want to find a10, I need to put in 10 for n here. So like that. 10 minus 1 is 9. 9 times 2 is 18. 18 plus 3 is 21. So an equals 21. So then I think this is one we can do just with our pencil and paper. So we'll get S10 is, well, 10 times 3 plus 21, all divided by 2. 3 plus 21 is 24, so we get 10 times 24 over 2. 10 times 24 is 240 divided by 2, and if we divide it by 2, we get 120. So our answer is 120 here. This one, we need to use the same geometric series formula that we used already. We can identify that n is 80 because we're adding the first 80 terms of the series. This G1 is 270. And then this is a little bit tricky, but I need to find the r. And so 270 times the r would give you 90. And so if we solve for r, we can divide both sides by 270. And we get r equals 1/3. And so r is 1/3. So then in our calculator, we can type G1 is 270 times 1 minus our fraction is 1/3 to the 80th, all divided by 1 minus 1/3. And our answer is 405. So there it is. Okay, the next ones say, do the infinite geometric series converge? Explain how you know if it does or doesn't. Okay, so what we're looking for is series with a ratio between 1 and -1. So if we have an r that's between -1 and 1, then we have a convergent series. And so I can identify that r is 5 here. And I can identify that r is 1/2 here. Only the r that's 1/2 is between -1 and 1. 5 is not between -1 and 1. And so I can say this one diverges or does not converge. This one converges. We know because 5 is not between -1 and 1. And we know that this series converges because 1/2 is between -1 and 1. Okay, so then the last problem just says, for the series in number 5 that converges, find the value that it converges to. We're going to use this formula. The only series we can use is this one because it's the one that converges. So let's just rewrite it really quick. Okay, all we need to know for this problem is G1 and R. G1 is 6 because it's what's written right here. And we found R in the previous step. We said R was 1/2. So then the series converges to S infinity is G1, which is 6, divided by 1 minus R, which is 1/2. Make sure to do the 1 minus 1/2 first, and so then we get 6 divided by 0.5. 6 divided by 0.5 is 12, so our answer is 12.